Alright, so in today's video we're going to be picking up where we left off last time. We started off with a 400 meter per second bullet weighing 23 grams that collides with a 500 gram block. In that last problem, which there's a link in the description to it, we found that once embedded, the block and bullet combo traveled at 17.6 meters per second in the same direction of travel as the bullet initially was. In this problem, we're given that the coefficient of friction on the surface that this is sliding upon is 0.3, and we're asked to find the velocity after this block and bullet combo travel 8 meters. The first equation we're going to use, the force due to friction, is equal to the coefficient that we were talking about times mass, gravity. If you're dealing with US units, that's just going to be times weight. That's the normal force in this equation. The next equation is closely related to it. It is work is equal to the force that we're dealing with, in this case the force due to friction, times the distance that force is applied. So force is times the delta x, which we know is 8 meters. We also are going to use the fact that a delta in energy, the change in energy is equal to energy final minus energy initial, with kinetic energy being what we're talking about, so that's 1/2 mass velocity squared. Alright, so if we come back up here to the top and start with this first equation, we say the force due to friction is equal to 0.3, that's unitless, times the mass. We're going to use kilograms as the mass, so 0.5523 kilograms. I don't quite have room to write that, times gravity, and gravity is equal to 9.81 meters per second squared. So plugging those numbers in, we get 1.54 newtons. A newton is equal to a kilogram meter per second squared. So in this case that worked out perfectly. Alright, so like we said, we're going to have work is equal to force times distance. So this work that we have, this is going to be equal to, now the work is it has a vector, as does force, so we know that this frictional force impedes motion. So it's a negative 1.54 newtons. It's negative because we say this is the direction of travel, so that's a positive. However, frictional force is in the opposite direction. It's the force that's trying to slow down motion, and it is negative. So we have negative 1.54 times 8 meters. Multiplying that out, we get 12.3. And if you're keeping up with units as you have to be, a newton meter is a joule. A joule is a unit of work or energy equal to a newton times a meter. So, can't forget that negative sign. Got that negative 12.3 joules of work. So, we have delta energy is equal to EF minus E initial, final minus initial. This energy initial is going to be kinetic, as we talked about, so 1/2 mv squared. Since we are talking about initial, we're talking about the moment that this bullet is embedded and it starts traveling 17.6 meters per second with a total mass of 523 grams, or 0.523 kilograms. So that's our starting point. So 1/2 0.523 kg times 17.6. And that 17.6 is meters per second. So plugging that in, we find that the energy that we started with is 81.0 joules. And as you can expect, as this slows down and deals with that frictional force, it's going to lose energy. So 81.0 joules is what we're starting with, as that's E initial. The delta is going to be the energy either put in or taken out, that combination of. We know that's going to be negative 12.3 joules, which is the work applied. So that's equal to EF minus 81.0 joules. So adding that together, we get that is 68.7 joules. So that's our final energy. We know that energy, as we've done before, is 1/2 mv squared. So plugging in what we know here, we get 68.7 joules is equal to 1/2. We still have the same mass, so 0.523 kilograms v squared. Now v is v final in this case, which we don't know. So dividing by 1/2 times 0.523 and then taking the square root of v final is equal to 16.2 meters per second. So in this we see that after the 8 meters of travel that the bullet and block go, it's lost about 1.4 meters per second off its initial speed. Alright, so that's your final answer on this. If I was able to help on this problem, go ahead and click like and subscribe.